we're looking at the stability and bonding notes, everybody. We know this. When are atoms chemically stable? It's something about their valence shell. What do they like to have?
When they are full.
Thank you. Yeah, we got one person. When they have a full valence shell, that's when they're chemically stable. Okay. So we're looking for. Oh, that color is horrible. Get rid of. Actually, I'm okay with that. I just want to look at full valence shell. They like to get that full valence shell. That will make them chemically stable. Okay, super fast review. We've said this a million times. What's the valence shell again?
The outside.
Yeah, the outside shell. It's the outermost shell. Okay, quick check-in question. Helium only has 2 electrons. Why do we consider it to have a full outside shell?
The first shell is full of 2.
Yeah, the first shell. Do you remember the letter name for the first shell? Yeah, nice memory. Yeah, the first shell. The first shell, which is the K shell. Again, I'm not going to use those letter designations. If you go into electrochemistry or like particle physics, you might end up using those. But the first shell is full with only 2. That's just like the one little exception to the rule that generally how many do they actually hold? 8 is going to be what other valence shells hold. What's the valence shell? It's the outermost shell on the atom. It's full with 8. It's called a teaching pause. I'm letting people catch up. Oh, oxidation number. We talked about it briefly before, but the people on the video maybe haven't heard this. What is the oxidation number? Does anyone remember? The charge when? Whew. Yeah, it's the charge. I'll just put it out in a nice sentence. The charge of an atom. Pen freaked out for a second. The charge of an atom after it gains or loses electrons to have a full valence shell. That's all the oxidation number is. Historically, the reason it's called oxidation number is when all of these numbers were first figured out by chemists, they were always using oxygen to compare. And so they were basically seeing, because oxygen really likes to rip electrons away, and they were kind of comparing like how many oxygens do you need to pull the electrons away, or how many oxygens are needed. They were referencing it according to oxygen, so they call it the oxidation number. That's just historically where that came from. Yeah?
That's supposed to be the axle or minus something?
Here?
Yeah.
It's E minus, which is my abbreviation for, thank you for asking, let's make sure everybody on the video gets that. I'm going to throw that in sometimes. You're right, this one was a little bit better. I was writing fast, sorry. Okay, we've already done this. Let's do some quick practice here. Let's practice finding sodium's oxidation number. The symbol for sodium again? Capital N, lowercase a. How many electrons does sodium lose to get its full shell? All I have to do is look at the periodic table, and I go, okay, sodium's there. It's got 1 valence electron. Is it easier to take 7 more or just get rid of 1? Yeah, it gets rid of 1. So it loses 1. And then what's its oxidation number? That's the charge after it's done that. So it's charged, let's see, it got rid of an electron. That's annoying that you get rid of an electron and your oxidation number is positive 1. Can you see the mistake people are going to make? They're going to think it's a negative because you got rid of, so that's a negative. But you got to remember, it's the charge afterwards. It's the way I think of it is it's very generous to get rid of an electron, right? Be like, here, take my electron. And that's like a positive thing to be generous. That's like a trick. Its oxidation number is +1. let's compare that to nitrogen. Nitrogen's symbol is capital N. How many electrons? Typo. Sorry. How many does nitro lose? Does it lose or gain?
Gain.
Oh yeah, it gains.
So now we get negative.
Oh. How many does it gain? Well, okay, how many does it start with? 5 in the valence shell, right? So is it easier to get rid of 5 or find 3 more? Yeah, 3 is shorter than 5. So it's going to find 3 more. So then, that's like greedy, right? It's like taking 3. So what's its oxidation number going to be? It's going to have a -3 charge because it's got 3 more negative charges on it, 3 more electrons. Oh, sorry. Take 3. Okay. So that's our oxidation practice. We're now going to move on to talk a little bit about what these oxidation numbers do for us chemically and how they sort of like show up in chemical reactions and chemical compounds. Speaking of compounds, has anyone heard the word compound before?
Yep.
Yeah, like back in like 7th grade, right?
Or third grade, compound words.
It's related to that, but this is the chemistry